Hello everyone, my name is Abhishek Chaudhary and today I'll be presenting a topic on targeting specific slave screens in Liquid Galaxy using Flutter for pre-requirement tasks of Liquid Galaxy for GSOC 2026. The main goal of this presentation is to explain how screen-specific targeting works in Liquid Galaxy, not just conceptually, but in a way that makes sense when you start building your own Flutter application. I'll first go through concepts and a mental model which explains how screen-specific targeting works, and then I'll provide a demo where I'll be generating my own KMLs and uploading it through a specific screen using screen targeting. The idea should feel very straightforward and reproducible for your own Flutter application. Liquid Galaxy is a multi-screen visualization system where Google Earth runs across multiple physical screens, but visually it appears as a one continuous display. This illusion of single display is what makes Liquid Galaxy so powerful but also confusing for beginners. When I first started working with Liquid Galaxy, my assumptions were that if I sent something from Flutter, such as a KML, it would appear everywhere by default. This assumption still holds until we do something slightly more advanced, such as sending logos to a specific screen and sending informational overlays on another screen. In real world Liquid Galaxy application, this requirement comes up very often. For example, when we need to send branding elements or informational overlays or dashboard which should not interfere with the main visualization. This is where screen-specific targeting becomes very important. In this presentation, I'll be solely focusing on how we can achieve that control using a Flutter application without touching any of the individual slave machines. To understand screen targeting, it is very important to understand the architecture of Liquid Galaxy. Liquid Galaxy runs on the architecture of master-slave, where one machine is the master machine and the rest of the screens are driven by slave machines. Google Earth runs on all of these machines, including the master and the slave machine. However, Flutter application does not communicate directly with all of these slave machines. It is a very common beginner mistake trying to SSH into each screen individually. However, that approach only leads to permission issues and a lot of confusion. Instead, Flutter only connects with master machine and the master coordinates everything. And all the visualization is controlled through KML files served from var/www/html directory. Once you internalize this architecture, many Liquid Galaxy concepts, including screen targeting, makes much more sense. Another important concept is how screens are numbered in Liquid Galaxy. Screen numbering depends on the total number of screens in the rig, and the center screen logic is used by the system. In three screen setup, the screens are logically indexed as screen 1, screen 2, screen 3. The center screen usually plays the crucial role of navigation and alignment, whereas the leftmost and the rightmost screens are in charge of branding or informational overlays. One thing worth mentioning is that screen numbering is often misunderstood. People assume that screen numbering maps from left to right, which is not always guaranteed. In production systems, screen numbers are often calculated dynamically, but in this demonstration, I'll be hard coding screen numbers to keep things simplified. This slide captures the core idea of the entire presentation. Targeting a specific screen in Liquid Galaxy is not done by Flutter directly controlling a specific screen. Instead, it is done by controlling where the KML is loaded. Each slave screen reads only one KML file named under the convention slave_xkml. So if I write a KML to slave_3kml, only the third screen and therefore the third machine will load and render its content. When the screen targeting doesn't work, people often believe that the Flutter logic is broken, but instead the KML is loaded perfectly just on another screen. Once the KML is loaded on the correct screen, the visual placement of the KML is done inside the KML itself using elements such as screen XY, oval XY, and rotation XY. So the key takeaway here is screen targeting is determined by file naming. and visual positioning is done inside the KML itself. Once this separation is clear, screen targeting becomes very predictable. Now let's briefly look at how Flutter fits into this flow. A Flutter application connects to Liquid Galaxy using SSH, commonly using libraries such as Dart SSH2. Flutter dynamically generates KML content as a string based on application logic or user input. This KML is then written to its appropriate directory, usually at /var /www /html /kml, and named according to its target slave. The KML file is also updated so Google Earth knows which file to upload. One important thing to note is that Flutter application by itself does not do any rendering in Liquid Galaxy at all. Flutter's only responsibility is to generate and transmit KML data. All rendering happens inside Google Earth on Liquid Galaxy machines. Instead of relying on static KML files, Liquid Galaxy applications often generate KML dynamically inside Flutter using Dart classes and helper functions. This makes it very easy to modify coordinates, images, positions, and even labels at runtime. This is very useful for interactive applications where content changes based on user input or external data sources. Generating KMLs in Dart also keeps all the application logic in one place, making the maintenance and debugging easier. This pattern is widely used across Liquid Galaxy applications. Once the KML has been generated inside Flutter, our next step is to get that KML content reliably onto Liquid Galaxy system. This is typically done by executing an SSH command inside Flutter that writes the KML string directly onto the appropriate directory inside the master machine. From this point onward, Flutter's role is essentially finished, and whether the KML content appears correctly or not depend entirely on how Liquid Galaxy processes the KML. This slide addresses one of the most confusing issues when working with Liquid Galaxy for the first time. Even after uploading the correct KML, the slave machine do not always reload the updated file immediately. What makes this tricky is that master machine often reflects the changes quickly, giving the impression that everything is working fine, while the slave machine continues to show the older content. This is the point where developers start questioning their KML logic or Flutter code, even though both are correct. The refresh mechanism solves this by configuring slave machines to periodically refetch their KML files. Once the refresh is enabled, updates to files such as slave_3 KMLs are picked up almost instantly without rebooting or refreshing the system. This is especially important during the development time where the KML files change almost frequently. Now that the mechanism is clear, it is important to talk about when screen targeting actually makes sense. Screen targeting becomes especially important when applications require elements such as branding or static overlays to remain fixed on specific screen. For example, you might want logos or static overlays to appear on one screen while keeping the central screen focused on navigation and data visualization. It is also very effective for dashboards and educational visualizations where different screens can show different layers of information at the same time. This allows the developers to design experiences that take advantage of the physical layout of Liquid Galaxy Rig. To conclude, Flutter does not control the Liquid Galaxy screens directly. Instead, they control the system indirectly by generating and uploading the KML files. Targeting a specific screen is achieved by placing the KML in the correct location and then following the correct naming convention. Slave-specific KML files provide a simple and a reliable way to control screen-level rendering without adding unnecessary complexity to the Flutter application. This is what allows developers to build immersive, flexible, and highly customizable multi-screen experiences. Once this concept is understood, Liquid Galaxy becomes much more easier to learn and much more powerful to work with. With this understanding in place, I'll now move on to a small demonstration showcasing how this all works in action. Now I will move into a small practical demonstration which will tie everything up we have learned so far. This demo is kept intentionally simple, where I'll start with generating my own KML, which will be a logo KML, just to have an easy to track and a visible piece of content. Then I'll briefly show the connection and the execution code so it is clear how Flutter application communicates with Liquid Galaxy master machine. After that, I'll upload the generated KML to a specific screen using the naming and the placement logic we discussed earlier. And finally, I'll switch to a Liquid Galaxy display to confirm whether our code is working or not. So without a further ado, let's get started. First, we will be making our own class. I'll name it KML logo. Next, I'll be adding a method which will be static and which will return us a string. Let's name it generate KML. Um, Inside this, I'll be adding a small wrapper which is required by Google Earth. And inside this, I'll add the document tags. Firstly, let's name these document tags. Name our document, sorry. Uh, we'll name it something like LG logo. Next, since this is a logo, we will be also be adding screen overlay tag. Firstly, let's name our overlay. We'll name it something like LG overlay. Next, we will be adding a visibility tag, which is required to make sure that our logo is visible. We'll give it a value of 1. Next, we will be also be needing an icon tags to add our logo through a link. Next, I will be adding some positional elements such as overlay XY, screen XY, and the size. Overlay XY is an anchor point on the image we put, and the screen XY is where we want that anchor point to be placed on the screen. Next is size. Size just gives allows us to resize the screen we are adding. So first, let's start with overlay XY. We'll give x value of 0 and y value of 1, and we'll have the units as fractions for both of them. Now this will be same for screen xy. But for our size, we will be adding units of pixels to make sure that logo is properly resized. I'll give it a value of 240 and y of 160. And we'll give x unit as pixels and y units of as also pixels. So there we have it. This is just me generating a small KML as a string. Before we continue with more coding, I want to talk about some codes. basically some snippets of code which are responsible for holding a connection between our Flutter application and Liquid Galaxy machine. Firstly is this connect function, which tries to create an SSH socket using our IP and port. And if we don't connect to SSH socket within 5 seconds, we time out. And if we are successful, then it wraps around that SSH using SSH client, using our username and password. And if we are connected, it changes the connection to true. And if we are not connected, it changes to false. And then it saves that state later on. Next, we have this helper, which is called execute. Um, it is used to check whether we are still connected or not whenever we send an SSH command. For example, here we have a force refresh function, which sends an refresh for our query.txt function. Here we first call our exec helper, which first checks whether we are connected or not. And if we are not, it calls the connect function to try to connect. And if we are not connected, it throws an exception where LG is not connected. And if we are connected, it then sends the command, which is our refresh command for our query.txt. So now that the connection code is clear, let's get started with coding our own send logo function, which we will be using to send our logo KML to a specific screen using screen targeting. I'll be naming this as send logo. Inside this, I will be adding two variables. One is logo screen, since I will be hard coding the number screen number. Next, I will be adding KML content variable, which will call our method which we made in KML logo KML. Next, we will be sending an SSH command. But before we do so, we will be calling our exec helper, which we've talked about before. And inside of here, we will be sending our SSH command. First, we will call our KML content variable. Next, we will send this to the directory we talked so much about before, which is var slash www/html slash slave underscore the screen we want it to be sent to. For us, it will be slave underscore 3, or we can also type it as slave underscore logo screen and then .kml. This is all we have to do to send our KML to a specific screen, but we should also add a force refresh since we are sending the logo to a specific or to a slave screen. Now that our backend logic is in its place, I wanted to quickly showcase how we can connect that functionality to our user interface, such as a button. So I'll quickly make a button here, which will have all of these named variables such as icon, title, subtitle, and on tap. And inside on tap is where we will be connecting our button with our backend code. So for icon, I'll give it a simple icon such as layers. And for title, I'll give it enable logo. For subtitle, I'll say something like enable show LG logo. And then inside on tap is where we call our send logo function. So now let's move on to the functionality of our code and let's check whether our code is working or not. Now that we are done with the coding part, let's test whether our app is working or not and whether the Liquid Galaxy logo has been sent properly to our screen using screen targeting. So first I will go to the settings screen and add my credentials. And it has connected. So let's press on enable logo and the logo should appear on the third leftmost screen. And as you can see, our logo has been appearing on the leftmost screen, and this is how we do screen targeting in Liquid Galaxy using Flutter.